Welcome to Subtropical Experiments. I don't hear myself in the house sound quite yet. Ah, there we are. Welcome, everybody. Yeah. One more time. How's everybody doing today? Thank you so much for being here. I thought it was going to be pouring, but is the sun shining or is it raining? I can't tell outside. Which is happening? I don't know. We'll see what happens next. Thanks for braving the weather and coming out for what is the final event of our series, Subtropical Experiments. We're talking about hurricanes today, a timely topic given that we're in the peak of hurricane season. And while we were all very grateful, we dodged Dorian. You know, we're all reaching out and helping our friends, family, and neighbors in Bahamas. So I'm really excited about this topic and that we're closing out with it. My name is Sarah Cruz. I work here at WDNA, Community Public Radio. I see a lot of familiar faces, but I always ask this question. How many of you is it your first time here at WDNA? Awesome. Thank you. Thanks for coming. So we're community public radio. The public part is what makes this kind of programming possible. We're about our listeners. We're about our community. And that means we're also about our local landscape. And so that's what this series is about. We're blending stories, science, and jazz for a little bit of a creative approach to how we understand our local landscape. So I want to briefly thank our sponsors, WDNA, for letting us have this here, of course. Thanks. And also our really great friends at Concrete Beach Brewery. Thank you, Chris. Yeah, they've been here with us for all 4 experiments, from Everglades to corals, water quality, and now hurricanes. And then thanks to our friends and neighbors at Tutto Pizza, just down the way on Coral Way. So we're going to start with our story aspect of things, which we're using that kind of loosely. It's been narratives, it's been experiences, and then we're going to go into our 2 science talks to help learn a bit more about the science of hurricanes, and then we'll have a Q&A, and then a brief intermission, and then we dive into our music to seal in the experience with Butterfly Snapple. So without any further ado, I want to get started with our story aspect of things. And I'm so excited. My dear friend, Dave Rodriguez, came down here all the way from Tallahassee, drove late at night to be with us here today. He is an audiovisual archivist, a filmmaker, and so what we're going to be seeing here today to kick things off is a piece of expanded cinema. And during the Q&A, I hope you'll ask him what that is, and he can give you the full explanation. So this is an expanded cinema set about the experience of growing up in hurricane season. Many of us grew up down here in South Florida. It's a very different experience, right, than maybe growing up other places and dealing with hurricanes. So let's dive right into it. Please help me welcome Dave Rodriguez and his expanded cinema project, Clavilux. One more time for Clavelux and Dave Rodriguez. Bringing the experimental to Subtropical Experiments. So store up your questions. I know I have a lot. So next up, I want to bring up Shannon Doherty, who has been my collaborator with this series. I've kind of coordinated the art and music side of things and communication, and Shannon has coordinated the science. So I'm going to bring her up, and then she'll introduce you to the scientists. Welcome, Shannon Doherty, please.
Hi, everyone. So we got the experiential part of our series with that awesome piece, and now we're going to dive into the science part of our series. So the design of this was to kind of demonstrate what the lived experience of being in South Florida is like, but also the science behind what drives that experience. So I'm a PhD student at the Rosenstiel School of Marine and Atmospheric Science at the University of Miami. That's a mouthful. We call it RASMUS. And we're out on Virginia Key. And I wanted to bring some scientists that I knew, especially scientists that were early in their career, that were very excited about sharing what they know with the community. So we have two speakers today. Our first is Kayla B. Song. She's also a PhD student at Rasmus. She studies atmospheric science, and when I asked her what she studies, she told me that she studies traffic jams in the atmosphere. So if you're curious about what that means, you should save that question for the Q&A and ask her. But today she's going to be telling us about climate and weather and how they're related and how they're not the same and what we mean when we use those two terms. Because I'm sure we've all heard weather and climate change bandied about on the news, on weather channels, and she's going to tell us about how they're related and what they mean and how they relate to hurricanes. So without further ado, Kayla.
Hi, everyone. So, as Shannon mentioned, my name is Kayla. However, I do not study hurricanes, so I'm kind of sorry about that. But yeah, I'll update tomorrow. It's fine. All right, so however, today I am going to be talking about weather, climate, in our daily lives. So before I get started, I want everyone to close their eyes. Close your eyes, and I want you to hold on to the first thing that comes to your mind when I say the word climate change. Okay, now open them. Was it one of these four pictures? Who thought about a polar bear? Yep, I knew it. But the point I'm trying to make about climate change is that it's much more than the common images we might automatically think of, right? Maybe some of you thought about any of these wild words on the screen. That's a lot. So let's go into something a little more structured, right? So let's think of our Earth as an ecosystem, or a balanced, sustained system comprised of people, planet, and profit, right? So along with that is a lot more. Right, so a lot of these other components, just to name a few, go into our sustained system of our Earth, okay? So we have things like human health, ecosystem health, business development, jobs, employability, political ideologies, social injustices, right? These are all part of our sustained system. And as we know, a lot of the time, systems have applied stresses, right? A little rock the boat, a little something? All right. But one of the main stressors to our system is climate and climate change. So we're going to talk a little bit more about what climate actually is. So what is it? Well, it's not weather, all right? Climate is not weather, and that's confusing, right? Because they go hand in hand, and a lot of people usually tie them together. So what's the main difference? Well, that difference is time, okay? So weather is the conditions of the atmosphere over a short period of time. Like in Miami, you know, the weather changes about every 30 minutes, if we're lucky. Whereas climate is how the atmosphere behaves over a relatively long period of time. And this behavior is usually at least 30 years or so, okay? So to further solidify this concept, we're gonna use my favorite analogy, and that's, what are you weathering, okay? So weather tells you what to wear each day, right? Today it's raining, you know, maybe you wore rain boots, a raincoat, but climate tells us what to have in our wardrobe, what to be prepared for, right? So our wardrobes are different than those in Alaska, right? So they might have more coats, scarves, that kind of thing, even though I know some of you get a little dramatic when the cold front comes through in December, right? But our climate is a lot different. So what's the point of this? Climate is what you expect, and weather is what you get. Awesome. So you guys are so smart. You're doing awesome. So we're going to take this to the next level. We know that climate does not equal weather. So climate change does not equal one extreme event. And it's so important to remember. Something like a hurricane does not equal climate change. You know, some of the effects of climate change could be affecting how some of these weather events are happening, but they don't mean the same thing, right? Because you guys know already that weather and climate aren't the same thing. So climate change and one event also aren't the same thing. Great, so you're still doing really awesome, so we're gonna keep going. So I made this cute little graphic for you guys. We're gonna go with it. So at this point here, any weather value that you want. I'm gonna use precipitation because it's been kind of rainy out, so pretend that's precipitation. Then the next day, it rains again, right? Maybe the next few days it goes up and down. It rains a little bit more, a little bit less. This is weather. Let's pretend we have like 10 days of weather going up and down. Maybe it rains, maybe it doesn't. More days more than others, okay? So then we'll find the trend of the weather for that week, right? So now we know what's happening. It's about normal, okay? So now, let's pretend we have that weather and we have that trend for one decade, okay? So instead of looking at a short period of time, we're looking about all those ups and downs for about a decade. And then we're considering 3 more decades, so 30 years. And what is the trend then? We have climatology now. Awesome. So we're seeing how the points are contributing to a general trend of how the atmosphere is behaving, or our climatology. Cool, right? So we're going to keep going even further and, dare I say, level up. So let's pretend that some of those points, one of the decades, the points go up just a little bit, just enough so that we barely even notice, okay? So then, how about even more after that? Another step up. Again, we might not even notice because we're still experiencing the ups and downs from our day-to-days. But maybe even those ups and downs are even more extreme, so it seems even more like nothing's happening, right? So maybe it's even more wet one day and even more dry another day. But what does this do to our trend? That trend goes up. So our climatology has changed. Our climate has changed from these series of points over a long period of time, okay? Awesome. So now you guys get weather, you get climate, and you get climate change. And you're probably like, wow, these are all really cute graphics, but how do you actually know this? Okay, can we have some science? Well, I'm glad you asked. Yeah, woo! STEM careers are great, I promise. Okay. So how exactly do we know, right? Greenhouse gases. And you're probably like, oh, here we go, right? Oh. But greenhouse gases are really important. In fact, if we didn't have them, we wouldn't be able to live on this planet, okay? Because the sun emits these waves, and they come to the earth takes some and emits some back out. If we didn't have greenhouse gases that act as a blanket to keep some of that heat in, like I said, we wouldn't be here. The problem is, kind of like the beers everyone's drinking, too much of one thing is a bad thing. So we're emitting fossil fuels, and we're turning our nice blanket into a weighted blanket, excuse me. So we're increasing the amount of heat that we have. Well, you could blame this on the millennials like everything else, but that's not the best option, because one of the reasons I told you that really bad joke is so that you might remember this picture. So this is our carbon dioxide concentrations going back 400,000 years, right? And so just as you would expect, and as you've heard, the climate is changing, right? It goes up and down naturally. But the problem is, ever since we came along around the Industrial Revolution and became addicted to fossil fuels, things have gone off the charts. And you can see that. We're right there. So again, not the millennials' fault. But, things are getting a little serious. Dun, dun, dun. Right? So if you keep perturbing a system, if you continue to poke the bear, you're going to have consequences. What are some of these consequences? We can read them up here. There's a lot of them. But due to time constraints, we're just going to talk about two that we're experiencing right here in Miami. And that's rising temperatures and sea level rise. So what are we feeling? You guys have learned so much already. You already know what's going on. What are we actually feeling? There's a lot up here, right? It's kind of confusing, but it's a lot of points, and they are actually all of the temperature records that we have broken this year as of September 8th in Miami alone. So 2019, this year, since January, that's everything. And this is from a really great scientist at UM, Brian McNulty. I'd like to thank him. But so these are all records. Right, and so if you think back to that little fun exercise with the cute little blue dots and the rising trend, yeah, these are our blue dots right here in Miami, okay? So what am I trying to say? So individual weather events are happening enough to shift the climate trend upwards, right here at home. And again, building on our cute little graphic, all those little points, here's a real graphic. Here's what those real points look like applied. And this is temperature around Miami going back to 1950, average yearly temperature. And what do we see? We see an increasing trend, right? And so what's the point here? It's to show that it's becoming increasingly easy to break record highs and increasingly difficult to break record lows, all right? So enough of the hot girl summer. We're going to keep going. We're going to go to sea level rise now. And again, there's a lot up here because we're feeling a lot from this type of thing. Okay, but the one that I want to highlight is our sunny day flooding. So since the early 90s, like when I was born, the global sea level rise has already risen 80 millimeters. That's not a lot, right? It doesn't seem like a lot. But on a sunny day, when you're sitting in traffic for 40 minutes and it didn't even rain, you're like, what is going on, Well, that's sea level rise, and you're feeling it. It's coming up, all right? And so then I took a lot of this information from the Miami-Dade government website. It's a great website. If you want to find out more about it, I highly recommend it. But imagine how much traffic we're going to be sitting in by 2060. So if you didn't feel doomed enough, we're going to keep going. So more climate impacts. I want you to think back to our sustained ecosystem, right? Our sustained people, planet, profit. Where else is climate change infiltrating? We have agriculture, right? So things like coffee, chocolate, they might become a luxury in the future. And that stinks. But we also have things like the environment, like our coral reefs, a lot of plant and animal habitats, they're in trouble. Water resources, human health and homes, social injustices, right? So this extends beyond what we're feeling, but what everyone is feeling. But I also don't want you guys to be doomed, right? You're probably like, this nice girl was supposed to talk to me about hurricanes, and I was supposed to learn things, and now I just want to buy out the bar. But the point of being educated is to be able to become more adaptive and more resilient to what's happening, right? So the better we know, the more we can become better at changing as our climate changes as well. changing with our climate, adapting, becoming more resilient. So right here in Miami with Hurricane Dorian, we responded. A lot of people are together trying to help out those people that happen. We need more of that. And building on being such a strong community, I don't want you guys to feel doomed. I never, with sea level rise and that type of thing, I never felt like Miami was gonna go under ever. I feel like we're gonna become the new Venice, Italy, but instead of gondolas, we'll be on our jet skis. We see you at the sandbar later, it's fine. Nothing ever happened, right? So understanding what's happening so we can become more effective and change with what's changing. The scariest part about climate change is the word change. So I'll just leave you guys with that. Thank you for listening.
Thank you, Kayla. So now we have some background about what weather is and what climate change is, and we're going to expand on that by adding hurricanes into the mix. So we have this background, and we're going to start talking about how hurricanes react with our climate and weather system. So to do that, another PhD student from the Rosenstiel School, Rebecca Evans, is going to come up and tell us about hurricanes and climate change. And when I asked Rebecca what she studies, she told me that she studies how hurricanes respond to day and night. So whether hurricanes sleep, whether they're nocturnal, whether they dream, and if they dream, what they dream about. So please ask her about that at our Q&A if you're interested. And without further ado, Rebecca. Take your beer. Oh.
Thank you. Okay, yeah, so I study how hurricanes respond to the existence of daytime and nighttime. I study their physics and their dreams. All right, so today I will be taking you through a whirlwind tour of hurricanes and climate change. Does anyone like my pun? Yeah, good, thanks. I like that. Okay, so I'm going to start with a definition from Urban Dictionary. What is a hurricane? Well, according to Urban Dictionary, a hurricane is a temporary alliance between the ocean and the sky with the goal of killing people. The ocean's ability to attack land is limited, so it lends the sky some of its water and energy so it can assault people further inland than it normally could. A little bleak. My personal favorite one is number 2. Definition number 2. It'll come up. It'll do it. Yeah, it's a restart button for your house. And that's all for good reason, because a hurricane, a very mature hurricane at any one time, has the amount of power, that the entire electrical generation capacity of the world has at the same time. So anywhere between 100 times, 1 time and 100 times, the entirety of all the electricity in the world is how much power a hurricane has, which is crazy. So hurricanes, I think, are super cool. This is one. You'll have seen images like this before. This is Hurricane Irma, right around sunrise when it was on its approach to Florida. And you can see some interesting features of hurricanes right here. So you can see the eye right in the center, and then you can see the flow around it, and you can see, night over here and day over here. So this is a particularly interesting storm for me. And a fun fact about hurricanes is that the coldest place in the world at any one time is at the top of a mature hurricane. There we go. So the coldest place on the Earth is at the top of a strong hurricane. It is about minus 100 degrees Fahrenheit. So fun fact, if you're looking at a satellite image of a hurricane, what you're looking at is ice. So there's actually a lot of ice in hurricanes, all right at the top of it. So what you're looking at here is swirling ice, which I thought was pretty cool. So now we'll go inside the eye to see what that looks like just for fun. So going inside the hole. So on the left, we have an image of Hurricane Katrina. So what people do here, the government sends some planes through hurricanes. They strap some instruments to it. They put some instruments on the inside. They fly a plane through a hurricane, and they take some measurements so that we can find out just how strong it is and stuff like that. So on the left, we have Hurricane Katrina. And fun fact about this image is that this image is the reason I wanted to do a PhD. So I went to a talk from a really famous hurricane scientist. He brought up this image, and I was like, well, cool, I'm going to do that. So here we are. So this is a very important image to me. On the right-hand side is Hurricane Irma, which might be more of an important image to you. And you can see that the inside the eye of a hurricane is really, really cool. Terrifying, but really cool. So you can see just this wall of clouds around the outside edge, and then this layer of clouds on the bottom. Here's a more recent one of Hurricane Dorian. So this was taken from Hopetown in the Bahamas. And you can see this person is standing outside their home during the passage of the eye. And it's crazy, this image. I stared at this forever. There's just this wall of clouds around the outside edge of the eye. And it just looks like a giant hole has been punched in the sky, which I thought was really, really cool. So if you're a maniac, you might decide to fly through a hurricane to get some data about it. And why would we do that? So we do it because we want to know more about what a hurricane needs. And what we know is that hurricanes are super needy. There's 3 things that they really, really need, right? So this is the Atlantic Ocean that we're looking at. They need a warm ocean, which I'll represent through fire. And the reason that they need a warm ocean is because that's where they get all their energy from. So they get, if the ocean's really warm, then they have more heat energy, and there's more energy for the wind. So they need a really warm ocean to exist. That's thing number 1. Thing number 2 is they need a humid atmosphere. So that means you need lots of water vapor in the atmosphere. In order for there to be clouds, you need to have water vapor. So that's thing number 2. And then thing number 3 is favorable winds. So basically what that means is that if a hurricane is about to form, all the winds around it need to not tear it apart. So there's 3 things that a hurricane really, really needs, and it's a warm ocean, a humid atmosphere, and favorable winds. And if we have all 3 of those, then we get a hurricane. So what I'm going to talk to you mostly about today is how these 3 things will affect hurricanes in the future. So what does our future hold? So we'll start with rain. Tropical Storm Allison was one of the wettest tropical storms in history. Lucky Allison. More recently, Hurricane Harvey dumped a lot of rain on Houston. And here's a graphic of Hurricane Harvey's rain. So in the middle of this graphic, we can see the city of Houston, and we can see that they got more than 30 inches of rain from Hurricane Harvey. In some places, they had, what was the highest number? 58? Or maybe 60. 60 inches of rain, which is about this high of just rain from one hurricane, because it just sat over the city of Houston for like 2.5 days or something. And they also, in some places, got a lot of storm surge. So what we know about climate change is that the atmosphere is expected to get warmer, and it's just a property of air that if air is warmer, it holds more water, so it can have more water vapor. And more water vapor means more rain. So with climate change, we expect a warmer atmosphere, more water vapor, more rain. So we might expect more events like Hurricane Harvey in the future, where we just have like loads of rain over the course of a couple of days. So that's thing number 1, is more rain. Okay. Next thing is wind. On the left, we have Hurricane Floyd, and on the right, we have Hurricane Andrew. One's a lot bigger than the other, which begs the question, does size matter? And the answer is yes. These 2 storms were exactly the same category. They were both Category 5, but you can see one is a lot bigger than the other. Luckily, Hurricane Floyd ended up going north and not really affecting Miami. But for those of you who lived in Miami during Hurricane Andrew, you'll know that that was very much not the case. So although size does matter, the little guys can still do some damage. So the reason I am telling you this is because these were both Category 5 hurricanes at some point, and with a warmer ocean, with climate change, the ocean is definitely going to get warmer. So what we expect from that is that there will be more energy for hurricanes. And like I said earlier, the more energy it has, the stronger the winds can be. So we might expect more events like Hurricane Floyd or Hurricane Andrew or Hurricane Dorian in the future, where hurricanes can just get like a whole lot stronger. So we've learned 2 things so far. We have that climate change will cause more rain, and it will also cause stronger hurricanes. Something to note at this point is that no one really expects hurricanes to get more frequent. Like, we'll still have the same number on average from year to year, so that's good. So we'll have the same number, just more of them will probably end up being stronger, which is kind of a bummer, so we'll move on. So the next thing is storm surge. So storm surge is the biggest cause of fatalities in hurricanes. And as you can see in this super depressing graphic I have for you here, is that if all of the ice melted in all of the world, which we don't expect to happen for at least another couple of 100 years, then this is what the shoreline of the United States would look like. So Florida's just gone. Bummer, so maybe don't buy any long-term real estate in Miami, I guess. Or if you're going for the new Venice, then do. So a storm surge will almost definitely get worse because of sea level rise, because if the ocean goes up, then more of it will come onto land whenever a hurricane comes by. So a hurricane will come by, it'll blow water onto land, and then we'll get slightly worse storm surge. So we've learned 3 things so far. We have more rain, stronger hurricanes, and higher storm surge. So all of these three things together sound like they're a bit of a bummer. So we think that this opens up some opportunity for fun. So this is Brickell during Hurricane Irma. As you can see, the streets are flooded. So there's opportunities for things like kayaking near your home, maybe swimming. Treat it as an opportunity, like Kayla said. It can all be fun. And then also we know in times of crisis, the community comes together to come up with a solution. So not necessarily a solution to climate change, but more just to try and drive the hurricane away. Here are some fun ones that I found. Shoot guns at Hurricane Florence to scare it away. Maybe don't. Point your fans at the hurricane to blow it away, which I like. Gathering all Spanish moms to get Irma in her place. And my personal favorite, ignore the hurricane because climate change is a hoax. Bummer. And then, so with that, I will summarize what we know about hurricanes is that with climate change, we expect rainier hurricanes, stronger hurricanes, higher storm surge, but luckily, no overall increase in the number of hurricanes, but the ones that do form will probably be stronger, which is a bummer. And with that, I guess we will take questions. Okay, I'm going to hand this back to someone.
One more time for our scientist, Rebecca Evans. And Kayla Bisong. And so with that, I'm going to ask our scientist and our storyteller, Dave, to come up. And we'll run into our Q&A. Alex, if you could hand out microphones to our speakers. So go ahead, come on up and take your places. We'll split you all up here. And we'll kill the overhead projector. So maybe come up a little bit, Dave. Yeah. Cool. So. All right. So while they are getting that set up, who has a question? Raise your hand. Any questions? You got to come way up here. Okay. Okay, we've got a question over there. Alex, can you mute the projector? Okay. So first question over here. Do you mind standing, saying your name, and what is your question? Go ahead, stand up.
Hi, my name is George Aguilera. I live here, and I've lived here for a long time. I just have a question about hurricane frequency and why we don't expect the number of systems to increase. Is that something that's based on the aftermath of a hurricane and like unfavorable conditions after that, or is it just like an actual space and temporal like restriction on how many can form?
Is it working? Okay, good. All right, so it's a very good question. So the question, is why would hurricane frequency not increase if hurricane intensity and stuff would? So the answer is basically that there's a bunch of competing factors in the atmosphere. So the ocean is expected to get warmer, which in theory would make hurricanes happen more often, except that other things are expected to be less favorable for hurricane formation. So like, I mentioned favorable winds, and the winds are expected to get less favorable in the future. So those two things are kind of competing with each other. And there's other things in the atmosphere as well. So the atmosphere would get more humid, which would be more favorable, but then other things would make it less favorable. So the two things just basically cancel each other out. So if a hurricane does form, because the ocean is warmer, they'll get stronger. But the likelihood of it forming is about the same in the future as it will be at the moment, just because the favorable things and the unfavorable things cancel out. Does that make sense? Okay.
Okay, next question right over here is your name and your question.
Hi, my name's Karai. Thank you so much. It was really interesting, and I really enjoyed the artwork as well. That's what my question is mostly geared to. So kind of at the center of what I felt was the extensive commodity production, which decentered, human relations and people which is at the heart of capitalism, of course. So I was wondering in how much a anti-capitalist perspective informed your artwork with all the building of the real estate and things like that, and whether that was a conscious decision or not to put that in there.
Yeah, man, you got it. Yeah, I mean, so in kind of putting this together and thinking about sort of like my own experience with Hurricane Andrew, I was 5 years old when Hurricane Andrew hit. Our house got wrecked and blown down. We lived in a trailer for over a year after that. So it's like one of my earliest kind of like memories is of like just my life being screwed up in this really significant way. Like lots of other people who lived in South Dade County, like this like becomes a part of you, and like it just kind of informs the way that you like look at the world and interact with hurricanes. And yeah, like in looking through a lot of the archival content towards this, like thinking about like hurricanes, like a lot of it is like framed as like it is a threat to capital, yet capitalism like fails to respond to things like climate change, you know? And that's where something like the idea of hyperobjects is really useful, because it kind of helps us kind of decenter humans from like what sort of like our conception of like time is. And like, you know, we think about like, you know, the way we've been trained to think about like, I think like time is like, you know, in this very shortened way, and that's something that capitalism does, right? You have to kind of look at what's profitable now and what's gonna make, you know, this next quarter, you know, sort of the most like lucrative and all of that. And like for us to like survive as a species, I think we need to break out of that way of thinking. And that's why capitalism is really unsustainable. Thank you. So yeah, and like, you know, so I'm thinking about this, and yeah, I think the next thing I make is just going to be about like just looking at like the real estate market and how the Miami real estate market like presents itself, because it is just like a treasure trove of like the capitalist imagination of like what the future is and what home is, and like it's just this really interesting thing. I just kind of went hard on that like corner of YouTube and pulled a lot of things out of it. But no, yeah, thank you for your question.
More question up here, your name and your question.
Okay, sure. Hi guys, my name is Laz. I appreciate your presentation. It was very great, and I appreciate your time. My question is about if the intensity of the hurricanes is going to generally increase, do you think there will be a new way how we categorize or classify hurricanes because of that? And furthermore, do you think there's any foreseeable necessary changes to county coding, infrastructure? Do you see any major projects or landmarks that are in extreme danger that might need to be significantly modified? What will we have to adapt to that you see is like a main go-get for now? That's my question. Thanks for your time.
I feel like both Kayla and I can feel that question, so I'll start with the category thing, and then I'll go over to Kayla for the rest. Right, so with the category thing is, you know, essentially, is there a necessity for a category 6 is something that we have been asked before. And for the most part, the scientific community has landed on no, because a category 5 and a category like 6 in theory would do the same amount of damage. So there's not much of a necessity to have a category 6. So I guess my answer to that would be no, but what the National Weather Service has started to do is put out products that show you the damage that you're likely to expect from wind and rain, and then they have a collective way to represent that, so that instead of category just being based on wind, that category might be based on different factors as well, like rain and storm surge, that are also relevant. So some people might disregard a hurricane because they're like, oh, it's only category 1, that's not really going to affect me, except that they might have lots of rain and storm surge. So I think the future of broadcasting for hurricanes would be to include more of that information in their broadcast instead of just focusing on wind. So for a category 6, I would say there's not much of a need for it, but for other products, I would say to include more things like rain and storm surge and tornadoes and that kind of thing in like one collective risk, if that makes sense.
Yeah, and in terms of your resiliency question with the infrastructure here in Miami, So Miami-Dade government is doing an awesome job at building your resiliency. So I've gone to a few things that they're building a sea level rise strategy, and they've already started doing a lot of this. So if you go to Miami Beach, there's a lot of construction. They're raising the levels of the roads right now. So they are working towards that, and that's awesome. They also are looking at different things such as seawalls, natural things in the ocean to help act as barriers for the storm surge. They're actually doing a lot. The last hurricane, the mayor, he is almost famous around the world for increasing his pump capacity and being one of the few people to respond to climate change. So yes, things are happening, and you should be excited that you have people looking out for you.
Next. Hey, next question. Name and your question.
How you doing? My name is Richie. So there's a lot here to kind of like talk about, but just trying to limit the time. I want to say thank you. I think all the presentations were wonderful, and I really appreciate you guys bringing like enthusiasm and energy to it. That's kind of dope. But I think also each of you like touched on something, and to bring in what my friend Korai was saying. When we I appreciate the model that you were talking about the economy and the society, the ideology, and I think people usually, like when you talk about capitalism, you think about, the economy, right? But like in reality, it's the economy, it's the ideology, the individualism, and all this stuff. This is the end of civilization. This is the best we can have, and they tell you how greedy and selfish humans are, and you do see some of that, like the old lady. I don't know if you guys saw it, but when Dorian came, an old lady was kicked out of her home because she had cats. And that was Miami Beach, and it was like still, it might hit us as a category 4 or 5. So she was just kicked out. So there's no morality or any kind of human conception to this economic structure, right, that's built on exploitation and domination. So I think that we have to really go deeper and start connecting all these struggles, and everything is interrelated. So I think that in order, if we do acknowledge capitalism as the problem, we need to find a solution to it, because it's a human-made world order, and it could be undone by humans. So if anybody agrees with any of this, I encourage you to please come see me after this. I'm actually part of an organization called Worker Struggle, and I'm ready and willing to talk about it and see what we can reach unity and discuss, see what can happen. But since I have to phrase this in the form of a question, got to figure this out. I'm going to ask the same question I actually asked last time, and do you actually feel like realistically, given the historical tendencies and trajectories that we've seen, do you think that it's actually possible for capitalism, which always needs more profit, is foresting and all this, to actually address climate change in the interests of the people, not the millionaires and the condos from the dope presentation? Thank you.
No.
I don't know.
Anyone else want to respond?
I don't know anything about money, so no. I have no money.
The next question here, and then we've got one over here. Your name and your question.
Hi, my name is Alyssa. I am actually also a student at the University of Miami, and what I study is data visualization and information design. So my question is, do you have any concerns about the way that hurricanes are, and sort of the threat of hurricanes, or maybe climate change in general, is communicated to the public, whether that's in terms of communicating urgency or the accuracy of what gets out there?
Yes. Oh man.
Tell me about it, please.
I don't want to go on this rant. I have the biggest rant about the cone. Oh my days. Okay. Right. I'm going to try and do this concisely. Okay. So you've seen the cone. Whenever you watch the news for a hurricane, you've seen like this is, where we think a hurricane's going to go. That's the cone. So what the cone actually means is that that's a 2/3 probability that the center of a hurricane will fall in that region. And that's based on the average error that the National Hurricane Center has had for the last 5 years. So the cone is the same size for every single storm throughout that year, which means that even if some storms have more uncertainty than others, that's not represented in the size of the cone. So people really misunderstand the cone. So they see the cone and they're like, oh, cool, I'm outside the cone. I'm probably fine. But that's not really true at all, because 1/3 of the time, the center of the storm will occur outside that cone, for one, but also the impacts of a hurricane spread really far outside the cone, and that's not represented at all in the way that data is visualized on the news in particular. So that's something I find really frustrating, because lots of people will not respond to hurricanes as a threat if they see that they're outside the cone. So they'll be like, I'm outside the cone, I'm not going to get anything at all, I'm going to have a beautiful pool day, when in reality that's not the case at all. So I have a lot of concerns about data visualization for hurricanes specifically, and the National Weather Service have done a really good job of putting out products that are a lot less easy to misinterpret, except that those haven't really been caught on to by the mainstream news yet. So they still mostly use the cone because people are used to seeing it. But the National Weather Service has products that are a lot more helpful if you're trying to determine your risk. So for hurricanes specifically, I have a lot of concerns for that, but for climate change...
Yeah, for climate change, I have a lot as well. I actually worry about this down to the point of color scheme, so I have a lot to say as well. So I'm gonna also try to make this concise, but it's hard to communicate climate change without making people feel panicked or doomed. And so coming up with creative and different ways to communicate things that you can do to become more adaptive and resilient, I think is important, and I think that that's something that's more needed. So.
Rebecca, you called me guilty when you said, oh, I'm outside of it. I was in my car for Dorian, about to head to my parents' house with my drill in hand to help them put up their shutters. And my mom called and she said, did you hear we're outside the cone of concern? I said, sweet. I'm coming over with my laundry anyway. But luckily, it worked out. Okay, so we're going to take our last question here. Okay, all right. One more and then maybe one more. Here, your name and your question.
My name is Al. First, I'd like to thank you for sharing the information, sharing the knowledge. And mine is a simple question. It probably falls in the realm of science fiction. Other than efforts to combat climate change, is there any technology or research other than Trump's idea of nuking a hurricane? Is there any research or technology that's focusing on deterring hurricanes or breaking them apart or any such?
That's a really great question, and so the first part of it is an ethical question. So even if we could deter hurricanes, should we? And the answer honestly is kind of no, because although they pose a huge risk to life, they're really important in the atmosphere because they transport heat from in and around the tropics to where the poles are, and they transport a lot of heat from the equator to the poles. And if they don't do that, I cannot even imagine the effects that would have on the global climate system. So that's thing number one, is that they're really important for the global climate system. So even if we could deter hurricanes, for that reason, we probably shouldn't. But the answer for whether we can is so there's been a lot of studies about whether or not these things are possible. And it would be extremely hard to execute. So one of the things is pouring ice into the ocean to make the ocean colder so that, hurricanes don't have as much energy to form. And the amount of ice that would require is outrageous. So how you would do that is not really possible. The idea of nuking a hurricane is something that we have also been asked before. And the difficulty with that is that hurricanes have between 1 and about 100 times the amount of energy that a nuclear bomb would have. So you would need quite a lot of nuclear bombs, and you would also have to hit them in exactly the right place. And given that hurricanes are in the middle of the ocean most of the time, you doing that and hitting it in the right place is really low probability for one thing. And then if you don't do it, then you essentially have a radioactive hurricane, which isn't really great either. So there's a whole lot of ideas that people have had. Whether or not they are executable in the present day is very, very unlikely. And even if you could do it, I personally would say that you shouldn't mess with the climate in that way, given how important hurricanes are for the climate.
Okay, now we're going to do last question. Your name and question.
My name is Michael. The first question is about climatology. How much, you talk about, somebody may say the year of 2019 is super warm and global warming is responsible. But how big is the amount of time that is studied, let's say when you're talking about climate change, versus the number of degrees? Is it 1 degree of Celsius per 1,000 years, or I was trying to get an idea of, is it possible to say that there's an average number divided by an average amount of time?
Yeah, so degrees per year, we've already risen 1 degree Celsius since around the Industrial Revolution. And then here in Miami, that graph that I showed you, back to 1950, we've already risen almost 3 degrees here alone. So global...
Wait, how many degrees? 30?
3.
30?
3 degrees Fahrenheit. 3, not 30, please. No.
Okay, 3 degrees
3 degrees since 1950, okay?
About nearly 70 years. Okay.
So...
But is that a standard in the climatology world? I mean,
No,
is there any?
that is not, because you'd have to think about the globe, right? Miami is really warm, and again, Alaska is really cold. And so when you average these, different parts of the globe are warming at different rates, right? So not everyone's feeling the effects of sea level rise, because not everyone lives near the coast, right? So similar to temperature, not everyone is feeling the same exact effects of climate change. Does that make some sense?
So
Another
average global rate, I don't know.
right, is there
It's been 1 degree since the Industrial Revolution.
okay. A question about the global warming. Is it too much of a leap of faith or too much of a connection to say that just because global warming is happening, that or that the sea surface temperature is going to be forecast to be warmer, that all of a sudden hurricanes are going to form?
Not so much that hurricanes will form, but that they will very likely get stronger because they have more of an energy source. So on average, they will get stronger, but like that doesn't.
Well, I'm just saying that just because the sea surface temperature is going to warm, does that mean necessarily that hurricanes are going to form? I mean, you're making a connection between warmer temperatures, automatically hurricanes.
Well, that's the main thing that they need.
Right.
So if hurricanes need 3 things to form and one of them is more prevalent, then it's more likely that hurricanes can form. So related to your question though, so how we attribute hurricane changes to a specific thing is that there's ridiculously good climate models out there where people can change so in a computer they will change the properties of sea surface temperature. So in some place, so they'll make it higher on average over the course of 100 years or so, and then so they'll just change that one specific thing to see how certain aspects of the climate respond. So like how many hurricanes you get per year and stuff like that. So they'll change the sea surface temperature, and then they'll bring it back to what it was before, and then they'll change like the humidity of the atmosphere, and then they'll bring it back to what it was before. So you can attribute specific like changes kind of in the so that's kind of the way that they do it is they change the greenhouse gas concentration in the atmosphere, so that changes specific parts of the climate, and then that changes the number of hurricanes. So you can attribute the changes in hurricanes to the one specific thing you changed. So for the scientific method of how we land at that answer, it's using really intense climate models that use the United States government supercomputer and stuff like that, if that helps.
Okay. So while we are going to wrap up our Q&A, please do feel free to come and chat more with our scientists and with our artist, Dave Rodriguez. We're going to take about a 15-minute intermission. We're going to do some stage swapping. So we're going to set up Butterfly Snapple over here. So please take a moment, grab another beer. I don't know if there's any food left, but there is some of that. Feel free to take a loop around the station, a self-guided tour, and we'll be back for Butterfly Snapple.
I barely taught drum set today, bro. I was just in a mode. I was just like drilling rudiments. I was like, nah, we can't move to the drum set unless we know like all these, and like they couldn't get past it, so we just didn't play drum set. I was wrecking them. I was like double paradiddle. Like, and if they didn't have it, I would just be like, all right, we're just gonna wait. They're gonna hate it, bro. I got one kid who's getting nice with traditional grip. Like it's starting to look good, and I'm like, yo. But he doesn't like swing yet.
Okay, welcome back, everybody. Thanks so much. Yeah, one more time. Yeah. Thanks again for coming out for our final Subtropical Experiments focused on hurricanes. Thanks again to Dave Rodriguez and Clavelux and Kayla Bisong and Rebecca Evans. And so now we seal in the experience with music, right? It helps us remember it, take it home with us, and we'll close out the series. And I'm really excited to introduce an awesome local band, Butterfly Snapple, accompanied with the projections of Clavelux. So please welcome Butterfly Snapple, Diego Melgar.
Thank you so much. We're going to just play music all the way through, so I'm going to get done with the introductions real quick. We've got, on the electronics, John Small. On the low end of the spectrum, we've got Camila Velez. Driving the bus today, we've got the one and only Xander Ambrose on the drums. I'm Diego Melgar, and we are Butterfly Snapple. If you look on my amplifier, we have cassettes for sale and stickers for free. Come and grab them once we're done playing. We're gonna just play all the way through, and I would like you guys to imagine you're in a impenetrable plastic bubble as a storm is passing by. So we'll experience the storm, the eye of the hurricane, and then the tail end of the storm. So thank you so much for listening. Thank you so much. Once again, we're Butterfly Snapple. You can find us on all sorts of social media accounts. You know, you've got your Facebooks, you got your Instagrams, you got your Spotifys, Bandcamps, all the usual suspects. Thank you so much for listening. Thank you to WDNA for having us, for the awesome lectures and the awesome visuals. I'm going to pass it off to the one and only Sarah Cruz.
One more time for Butterfly Snapple. And one more time for you all, thank you so much for coming out to WDNA. For Subtropical Experiments, thank you for taking the time to learn about your home. I hope you take this information with you and carry it, share it with others, find ways to activate it in your everyday life. This is the close of our Subtropical Experiments for the summer. Thank you so much. If you want to find out more about what's happening at WDNA, you can sign our email list. We also are on all the social media. So you can follow us there, tag us in your photos, because I know you all took some nice photos and videos of all of that, didn't you? Yeah, I thought so. Thank you again so much. Have a great rest of your weekend. Thanks for joining us. Farewell.